Dr. Julia Pearson in Quarantine Zone 51. We have lost containment. I repeat, we have lost containment. I am requesting immediate military assistance to facilitate the evacuation of all personnel.
Okay, listen up. Ground reinforcements are on their way, but it could take Bravo Company days to fight their way through that hellhole. So we're going to send a priority team via Helo to get Pearson and her research out. The plan is for a rooftop exfil. She'll meet you up there once you're overhead. Now, that facility's packed with civilians, including women and children. Let me be clear, they are not your concern. Just get Pearson out of harm's way and back home. Mayweather and his Marines are on site. We feel confident they can hold the line until Bravo gets there. It should be a walk in the park, gentlemen. You have your orders. Move out!
Command Central, come in. Command Central, can anybody hear me? Eagle 1 is down. The mission is a bust. Everybody's dead. I'm the only survivor. I'm gonna try and make my way to the Lady of Hope Hospital and rendezvous with Mayweather and his Marines. We're trying to fly over the facility. Look dark already. I repeat, it looked dark already. Can you hear me, Command Central?
Hi everyone, and welcome to the Dead Earth game development course here at the Game Institute. In this course you are going to learn how to build a first-person shooter survival horror game using the Unity game engine. Now this is going to be a long but very exciting journey, as you will learn to build every component of this game from the ground up. I'm Gary Simmons, the lead developer of Dead Earth and your primary course instructor. And in this first video, I want to discuss some very important topics before we get started, so as to make sure that you get the maximum amount possible out of this whole experience. I want to talk a little bit about the game that we are going to make, any prerequisite knowledge and experience that you should have before embarking on this course, how to download and play the final game, the order in which we will cover the various game subsystems in the course, and finally, which version of Unity we would recommend you using, as the most recent is not always the best choice from a learning or performance standpoint. Finally, We will also discuss how to access the course's accompanying project files and resources, and the tools that you need to have installed on your computer to successfully access and extract them for use. At the very beginning of this lesson, we saw the intro sequence to the Dead Earth game, and it sets the scene for the first level of our game very nicely. As the sole survivor of an ill-fated rescue mission into Quarantine Zone 51, the player will inhabit the intrepid hero of our story as he descends into the Lady of Hope Hospital to find and possibly rescue Dr. Julia Pearson and her research team. But by the time our survivor reaches the facility, it has gone dark, and the rescuees are not on the hospital rooftop waiting for extraction as originally planned, so something has gone terribly wrong. Within the hospital walls, our player will need to investigate what has happened to the research team while simultaneously solving puzzles, employing stealth tactics, and battling zombie hordes. If you have not yet played the game, then you can fetch a playable demo of the first level from the resources section of this Dead Earth course. Alternatively, if you would rather watch me playing through the entire first level while I discuss some of the game's mechanics, there is also a video playthrough in the projects area also. Throughout the various lessons of this course, we will be writing lots of new scripts or updating previously written ones, as well as, at times, instructing you to import new assets that we provide. These additional assets and the scripts that we write within these lessons will be available for download from the resources area of this course, as shown here. You will be instructed within the lesson videos as to when they are needed. With respect to the scripts, in the earlier lessons we encourage you to type the scripts in yourself along with me in the videos. We feel that this will better embed the knowledge and, of course, get you used to writing your own scripts and debugging any errors that you might make. However, for convenience, any scripts written in a lesson will be available for download from the resources area in a download link that matches the name or number of the lesson. As we progress on to the more complex topics in this course and the scripts become longer, you will most likely want to download the accompanying scripts for that lesson and import them into your project to save you all of that typing. But like I said at the start, when the scripts are smaller, we encourage you to type them in yourself and help flesh out your skill set as a Unity developer. Now, a free piece of software that I would very much recommend you install at this early stage is an application called WinMerge, available for download from winmerge.org. This is useful if you have typed in the script yourself and are getting errors that you cannot remedy. WinMerge will allow you to compare your source code file with the one that I have prepared for you in the resources area and will highlight the differences between the files. This will allow you to easily locate any typos you may have made. While most of the smaller scripts and code updates discussed in the videos can be found in the resources section of this course, at certain milestones throughout the course we will make available the downloading of the complete Unity project as it is so far up to that point. This will assure that if anyone has drifted too far off course and are having difficulties, that they have a chance to download the project and become synchronized with the course videos. Once again, you will be notified in the videos when these are recommended to download and use. These bigger milestone projects, however, are not in the resources area of the course, and instead you will need to pop over to the projects channel, which you can get to from within your Game Institute dashboard. Due to the very large size of some of these project downloads and to abide by our website file size limits, some of these projects will have been broken up into multiple files using a free piece of software called 7-zip. Here's an example of such a project download broken up into several smaller files, which you can then download individually. You will also need 7-zip installed on your computer so that once you have downloaded the collection of files, they can be reconstructed back into the original larger project zip file. 7-zip can be downloaded for free from 7zip.org. Although we include instructions with the download on how to use 7-zip, it's very easy. Once 7-zip is installed and you have downloaded the relevant files, simply right-click on the first file in the collection and from the 7-zip context menu, select Extract Files. Once the extraction is complete, you will have a single folder in the location you chose to extract the files to containing your Unity project. The original files that you downloaded from the Game Institute website can then be deleted. They are no longer needed. Also, just a heads up guys, if you do download any of these files from the site, you will lose your ability to request a refund, even if you are within the typical 30-day window we allow. So make sure you watch a few videos first, and just make sure that this course is definitely a good fit for you before you start downloading our source code and assets. That's just something to bear in mind. Oh, and one additional thing related to assets. When we first started developing this course, it was intended that we would use assets purchased from Unity's asset store, and we would require students to purchase those same assets too if they wanted to follow along with us exactly. Because that would mean our projects would contain these third-party assets, we wouldn't have the permission to redistribute them to you. This meant that we would never be able to give you access to an entire project source, or the smaller milestone projects along the way. However, as the project progressed, we decided that it would be a much better experience for you guys if we did away with that idea and just created all of our own assets in-house and made them available to students at no additional charge. So that's what we did. This course includes hundreds of high-quality game assets which you can use while following along with the course, and you don't need to buy anything else. And it also enables us to give away the complete Unity game project to you guys. The only reason I mention this is that there may be one or two places throughout the videos in this course where I mention the purchasing of these assets and perhaps even recommend that you do too if you wish to follow along. Please feel free to ignore this. Everything you need for the course can be found right here in this self-contained package, integrated directly with the project downloads that you have access to already. Making a computer game by yourself or with a small team is a very long job indeed, especially if you are responsible for creating all of the source code, the assets, the sounds and the music. Even large software houses with hundreds of employees can still have a game in development for many years. Making a game at the same time as recording hundreds of hours of tutorials is an even longer job, and at the time of recording this video, Dead Earth has been in development for approximately 5 to 6 years. Now, when I started developing Dead Earth, the latest version of Unity was 5.3. Now, that version seems like a long time ago now. However, in Dead Earth we deliberately tried to rely on just the foundational features of the engine that have continued to work unchanged in all versions of Unity since that time. Now, at the time of recording this video, Unity is currently at version 2021, and as you can see on screen, the Dead Earth project works perfect in this version of Unity as well as all of the other versions that have come and gone in between. Of course, we will continue to update the source code if anything should change on that front, so we will always have a project running in a fairly recent version of the engine. Therefore, within reason, it doesn't really matter which version of Unity you use in this course with respect to the code still working. However, although the logical choice might be for you to download and install the very latest version of the Unity engine, that is not always the best choice, and I would actually recommend you installing a version of 2018 LTS, which is short for Long Time Support, and use that to follow along with me in this course. Now, I'm going to show how to install additional versions of Unity via the Unity Hub in the next video, so you can have this version installed alongside the very latest version of the editor if you so desire. So why is 2018 my recommendation? Well, a couple of reasons. First off, we are not using any of the new or experimental features in the later versions of Unity, so there's actually no benefit to us having the later version installed just for the sake of it. Furthermore, many of these newer features added to the editor, which we will not use, in my experience really does slow down the editor a fair bit. I developed for years in 2018 without a single crash, but in 2021 I have experienced quite a few crashes and stability issues within just the very short space of time that I've been using it. The editor also seems pretty sluggish and non-responsive at times compared to the 2018 version. In addition, I have seen many people complaining on the Unity forums that they are seeing a performance drop in their games in the later versions of Unity. Many say that it has been degrading a little bit in performance with each release since 2018, especially so far as using the built-in pipeline is concerned. Now, I can't personally attest to that, but having now an upgraded version of Dead Earth in 2021, I am definitely seeing a fairly significant drop in performance. Now, Unity Technologies have answered their critics on their forums by stating that this is not actually the case. They make the point that in later versions of Unity, the reporting of statistics, such as the frame rate, are more accurate, which means you only thought you had more frames per second in earlier versions of Unity, but they were reporting the frame rate incorrectly. However, setting aside Unity's reporting tools, I personally have timed the frame rate myself with our own custom code, and I am definitely seeing a performance drop, not just in the editor but also in the built game in 2021 when compared to the 2018 build. In some of the most demanding parts of the Dead Earth game, where in 2018 I was getting around 60 frames per second on my setup, this drops to about 40 frames per second in 2021. Now 40 frames per second is still acceptable, I don't have a super fast computer or anything like that, but it is still a significant drop. And at the high end, things are even more strange. In more performant parts of the Dead Earth game, I could see my frame rate reach perhaps 250 or 300 frames per second in 2018, whereas in 2021, it almost seems like it's limited to a maximum of around 120. Once again, 120 FPS is still perfectly acceptable, but if you want the best performance from your game using the built-in pipeline and you don't require any of the new or experimental features in the later versions of Unity, the 2018 version of the engine is going to get you the most performant build of the Dead Earth game. Having said that, if you really want to use the latest version of Unity and you don't mind taking the hit in performance, then feel free. But personally, if I were building the Dead Earth game today for retail consumption, I would still definitely build the final game in 2018 for performance and stability reasons. And of course my final reason, although admittedly a less important one, is that for most of the videos in this course, certainly from around video 40 upwards, I think it is the 2018 version of the editor that I am using in the videos. Now that doesn't really matter as the editor UI has changed very little over the years, but something else to bear in mind. Now, as this course has been in development for such a long time, in some of the earlier videos you will actually see me using Unity 5.4, then upgrade to 2017 and then to 2018. But like I said, the UI barely changed between these versions, especially for the features that we are using. Virtually identical, so there's not going to be any problems with you following along even in the early videos with 2018, or with 2021 for that matter. Like I said though, I recommend 2018 for the smoothest experience, and I will show how to install that in the next video. Now, having said all that, as we constantly work to update and improve the Dead Earth course, I am not ruling out that at some point in the future we might release versions of the project that require newer features, such as the version that uses the scriptable render pipeline or the entity component system, and therefore would require a newer version of Unity to be installed. But if or when this is the case, there will be a separate download with supplementary videos, and this won't be part of the core course. The journey you are about to go on is going to be a very long one, and it will require dedication and perseverance. While it will be challenging at times, I am very certain that you are going to have a lot of fun doing it, and I can promise that when you get to the end of this course, the skills you have as a Unity developer will be very impressive indeed, and your confidence as a game developer will see a significant boost. If you understand the material that we cover here, you will be able to take on almost any game development challenge that comes your way in the future, and you will find working in the Unity environment much easier and more comfortable. So whether you're taking this course to prepare yourself for something like a Unity certification, for example, or you're trying to build a portfolio to seek an employment opportunity, you will find this course enormously helpful. Even if you're just doing this to impress your friends and family with your own cool games, we've got you covered. Making a game such as Dead Earth is a pretty advanced topic, and therefore this is a pretty advanced course. So the last bit of business I want to go over is just what skill level you should be at and what prerequisite experience you should have in place to achieve success in this course. Now, building a game like Dead Earth is a huge undertaking. We have hundreds of hours of very detailed Unity coverage. But this course assumes that this is not your first Unity game development project, and that you've at least built one or two fairly simple games in Unity before. It goes without saying that you should also be very comfortable either programming in C# or some other object-oriented language. So if this does not describe where you're currently at, I'd really recommend taking the time to prepare properly before diving into something this advanced. The C# programming courses and the Unity Game Academy course here at the Game Institute are great for getting the fundamentals you need in place. The Game Academy course will provide you with the Unity basics you need for Dead Earth, and I believe that course also uses Unity 2018 as well. So we will have some synergy there too, and this course will get you building a few simple games. Once you've done that, you'll be ready to take on this course and should have no problems at all. Let's finish up this video by discussing the topics that we're going to cover in this course and the order in which we're going to cover them. This will be by no means an exhaustive list, as there is just so much to this course, but it will give you a rough idea about the main segments of the course and the order in which we are going to cover them. The non-player characters in our game are going to need to be able to navigate the game world in a seemingly intelligent way. If we wish a character to pursue the player, for example, we can't simply move the character as the crow flies directly towards the player in a straight line, or that character is going to be passing through walls, mountains, doors, parked cars, or cupboards, or any other solid objects comprising our scene. So we're going to be looking at Unity's navigation and pathfinding subsystems. We're going to learn how to build a graph that describes the traversable areas of our world and how they are all connected by building a data structure called a navigation mesh, or NavMesh for short. The NavMesh is constructed by analysing the geometry in the scene and trying to determine, using a set of rules that we dictate, which of those polygons in our scene represent walkable surfaces. A mesh is then constructed, called a navigation mesh, comprised of just those surfaces deemed walkable by our AI characters. Paths can then be plotted between 2 points in the scene by using the vertices of this nav mesh as the waypoints. The vertices or waypoints can then be fed into a pathfinding algorithm to find the best or shortest path between these 2 points. And we're also going to look at Unity's pathfinding component called NavMesh Agent that can be used to plot efficient paths throughout the game world and also traverse those paths using the previously generated navigation mesh. Now, the navigation meshes that are used by Unity's pathfinding subsystems are compiled at development time, meaning they're static, and therefore they can't factor in dynamic entities such as other NPCs or moving objects. So I'm going to show you how we can use Unity's nav obstacle component to allow our dynamic characters to avoid other dynamic entities as they follow their paths, and also how we can use them to dynamically alter the navigation mesh at runtime to cater for portal situations, things such as doors opening and closing that might enable or disable routes that the AI can take. Now, pathfinding and environmental traversal is just one part that's needed for our artificial intelligence system. So once we've learned how to do that, we're going to need to write code to control the decision-making process of our NPCs. It's not just about knowing how to navigate from one place to another, it's about knowing why you would want to and when to navigate there. The zombie AI in Dead Earth will have many properties and states, all that will be invoked based on external stimuli. A zombie will obviously react to any player that enters its field of view and go into pursuit mode and relentlessly chase the player, but our zombies will also be sensitive to sound, light and smell as well. If a zombie hears a sound, for example, it will try to investigate the source of that sound. Similarly, a zombie may be facing away from the player so that he doesn't know the player is there, but if you shine your flashlight in its direction, it will become aware of the increased illumination happening around it and will try to track the source of that light. Our zombies will also be sensitive to the smell of blood, so even if the player is as quiet as a mouse or hiding in shadow, if the player is badly damaged and bleeding, our zombies will be able to track the player's location using the scent of the player's blood. Furthermore, we will also throw in some other interesting behaviours as well. For example, our zombies in Dead Earth will have a hunger property that will drain down as it patrols the game world. A very hungry zombie will see a dead body laid on the ground and will deviate from its patrol or pursuit target and go and have a feast on that corpse. As Dead Earth is at its core a zombie shooter, it stands to reason that a large part of the first section of this course will be dedicated to writing an intelligent, robust and easily extendable zombie AI. Unity has a very powerful animation subsystem called Mechanim, which our game will rely heavily on for a variety of its functionality. We will see how to import characters and animations and how to retarget animations from one character to another. That is to say, we will see how animations originally created for one specific humanoid bone hierarchy can be used on all of our other humanoid characters, even though their bone hierarchies share different names and configurations. We're also going to see how we can use the root motion stored in our animations to update the positions of our NPCs in a way that makes their movement look much more organic and reduces foot sliding. We're also going to learn how to build complex multi-layered animation state machines to control the blending of our NPC's animations between the different states, using a state machine to handle all of the timing and transitions from one animation state to another, such as transitioning from a walking state to an attacking state, for example. We're also going to see how to use avatar masks to restrict certain animations or layers in our state machine to just specific body parts of the character, and we'll see how layers can be blended with other layers using layer weights. We're also going to learn how to make use of animation curves, animation events, and state machine behavior scripts that will allow us to drive events in our game directly from our animations. This is a very powerful feature. For example, we shouldn't just assume that a weapon should be fired when the user presses, let's say, the mouse button, right? Instead, the button press should simply express this intention to the animation state machine. The animation state machine should trigger the firing animation, but it will be the animation curves on the firing animation itself and the state machine behaviors on that animation state, which will tell our code the correct point in the timeline of the firing animation that the shot should actually occur. Of course, you can't create an atmosphere in a game with graphics alone. Sound is also crucial to a fulfilling player experience. We will look at using Unity's multi-track audio mixer and write a flexible and reusable audio manage to manage all of our audio sources and music in real time. We will look at how to create a pooling system for one-off sounds to make audio instantiations more efficient and cut down on the C# garbage collection. At this point, we will also take our first of many looks at Unity's scriptable object class that will allow us to create custom assets that will bend the editor and the development experience to our will. We will then design a flexible framework for representing all of the interactive items that will exist in our world and how they interact with the player. Whether it's weapons or ammo you are picking up and adding to your inventory, doors that you are opening or closing, switches you are activating, elevators you are riding, or a lock that you are picking, all of these items will use our interactive framework as their base. This will provide us with the ability to create any bespoke object in our world that we can imagine and easily code its interaction with the player.
Report back once you've...
We will then look at techniques needed to create a UI or HUD for our game. We will learn how to update the UI during gameplay to accurately show the player's health and stamina at all times. We will also write our first image effect shader so that as the player gets more damaged, we will see the screen become more and more bloody. At this point in our training, we will put everything we have learned so far to use by creating a mini-game called Creeper. Now this is going to be a very simple game which will just see the player being attacked by zombies, riding elevators and completing mission objectives to complete the level. Like I said, it's going to be incredibly simple compared to the final Dead Earth game that we're going to create, but it's going to be a really good test of bringing together everything that we have learned so far up to this point. Next up, we will focus on creating a multi-purpose and extremely expandable inventory system and its accompanying UI. This will not only include the inventory system and the UI itself, but we will also show many examples of different collectible items, essentially items in the world that can be picked up and added to the player's inventory. Initially, we will focus on creating simple items such as weapons, ammo, health kits, flashlight batteries and keys, but later on we provide examples of many more items including maps to more easily navigate the level, books and journals which can be read to further the storyline, and crafting ingredients that can be collected and taken to a crafting station to repair weapons or create entirely new items. As part of the inventory system, we will also implement a cool PDA playback device so that we can store and playback from our inventory various audio logs with captions that we find throughout the game world, and these are also used to further the storyline and provide some additional backstories on the other characters inhabiting our game world. At this point in the course, we will return to our AI codebase and up the complexity a little. We will implement subsystems so that our NPCs can achieve tasks such as opening doors, navigating stairs, and deal with forbidden navigation areas. As good as the Unity engine is, as we keep adding more models, lights and geometry to our scene, we will see performance suffer significantly. While Unity has a built-in occlusion system that stops invisible objects being rendered into the frame buffer, even invisible objects still have to be rendered into the shadow map. Now, in a light map-based scene, this will provide a serious boost in performance. It's probably all you need. But in a project like Dead Earth, where we are using real-time lighting, and we also have an awful lot of lights in our scene, Unity's occlusion culling really isn't going to help much, if at all. You see, during occlusion culling, the mesh culling process happens after the scene has already been rendered into the shadow map, being used by the dynamic lights. So although we don't render or light the objects, we do end up rendering the whole scene into the shadow map. So to remedy this, we will create a PVS system. Now PVS is short for Potential Visibility Set, and this system will allow us to set up the level so that only the meshes and lights that affect the player's current view of the world are processed. This will provide massive improvements in performance, and furthermore, the PVS data will be used later on to provide us with many other benefits as well, from muting audio behind a closed door to disabling expensive animations and obstacle avoidance on AI characters that cannot possibly be seen by the player. Next up, we will create another subsystem that links to our inventory system, and this will also give us a chance to write another custom image effect as we implement our night vision subsystem. Just like the flashlight, the player will have a pair of night vision goggles that run on batteries, and therefore, its power must be managed in the same way. And like I said, this will also involve writing another custom image effect shader as we implement that very well known green noisy camera effect that we're used to seeing in the night vision modes of all of our favourite AAA games. The player having an inventory is cool, but imagine if all of the characters in the world also had their own inventories which you could loot once you had killed them. We're going to implement this next. In fact, any item in the world, not just NPCs, can have item collections assigned to them and therefore can become a loot source. This means, to give some examples, we could examine debris to find a sharpening stone to repair our axe, or loot broken machines for wire and scrap metal to repair or create new weapons, or perhaps kill a zombie nurse, loot her inventory for bandages, syringes and painkillers, etc., and then take those items to a med station to craft a health kit or an anti-infection kit. We will even implement a new type of project asset called a loot table that can be used to randomly generate the loot for an object based on a set of probabilities that we set up. In Dead Earth, there are numerous ways that the player can become infected, be it bitten by a zombie during an attack or bitten by infected mosquitoes hovering around a dead body. Once infected, that infection has to be managed by taking anti-infection medication, which can be found or crafted throughout the game world. We will build an infection management system and an accompanying image effect so that when the infection is left untreated by the player for long periods of time, a fever will kick in that will affect the player's sight, hearing and maneuverability. This is a really cool subsystem that I'm very happy with. We will also implement a mission system that will make it incredibly easy to set up any type of missions that you require. Missions can have multiple sub-objectives that must be complete to complete that mission, and the player can be assigned multiple missions at one time. Based around a simple game state system, mission objectives can be almost anything you can think of, from killing a specific NPC to finding a key, unlocking a specific door, finding and listening to a PDA of a specific character,
for the Center of Rage Research. My mapping data of the Rage Namite is now complete.
repairing broken communication equipment, downloading files from a computer terminal, learning a password, or even locating an old power generator and restoring power to the level. We will even implement a mission objective that involves finding the decapitated head of a scientist and using that head to bypass a retinal scanner that is currently keeping us out of an important location. A single mission could contain just one of these objectives, or it could contain all of them. And this is just some of the examples that we are going to develop. And after everything discussed here, I am still really just skimming the surface of what you will learn and the systems that you will get source code to. For example, how about a complete lockpicking system? a top-down real-time minimap system, the ability to render outlines around meshes to highlight the fact that the player can interact with them, meat suits that can be harvested from a zombie's rotting flesh and worn by the player to evade detection, cinematic sequences using Unity's timeline, and the ability to have the player smash objects into pieces with realistic physics. Boy, we have a long way to go, but what a journey it's going to be. So now we have all of the business talk out of the way, let's leave it there for now, and in the next video we will begin the process of creating Dead Earth. Bye for now.